Well, the stream of highly technical, heavy business hitter Renaissance men continues. And our next speaker is a very interesting character indeed. Very different character as well. Ingo, well, they're all characters. They're all very unique individuals. What can I tell you about Ingo? Well, he's got a very interesting and diverse background. So, on the one hand, he's been there and he's done that. He's worked in manufacturing and management. He's worked in market research. If I recall correctly, I met Ingo shortly after he first arrived in Australia, basically to be the point man for Salford Systems. And those of you who haven't heard of Salford Systems, you should. They're a very important vendor in the software space in the analytics industry. Salford System, run by Dan Steinberg, has great names such as Jerome Friedman and Leo Brayman on its books, the late Leo Brayman, I should say, the people who created the card decision tree, Mars, gradient boosting, and random forest, which is awesome. And speaking of Leo Brayman, he was one of Ingo's lecturers at university. So Ingo has since then done a PhD in choice modeling under Jordan Louvier, who's one of the creators of the field of choice modeling. So Ingo comes with a rather impressive pedigree as well as tremendous real-world experience. But what he's going to tell us about today is rather interesting and theoretical, and it's the use of card decision trees for dealing with messy data and missing data imputation. Take it away, Ingo.
Thanks for the intro. Hello. All good. So yeah, pardon me. I'm still as I went back from industry back to academia. I think most people do the reverse, right? They do academia and then go industry. So forgive me. I always do old school notes. Old school Beamer, latex, sorry. Okay, so what today's talk, I've gone to a lot of these talks, be it surf, be it data science, Sydney talks, the marketing analytics with Nico, those talks. And it's always cool, it's always good techniques, and that was really cool what you just did, Rainier. But I always thinking, well, geez, okay, data science, well, what about the science of the data? And so when I go to, because I kind of wear two hats, like Eugene said, been in industry, but I also as a pedantic academic. So when I go to, data science talks, professional talks, and then I go to the joint statistical meetings and the stats talks, and it seems to me like I'm hearing two different messages. So the statisticians are like, hey, nobody's looking at the data, the sampling's all wrong. And so, so here we're getting really cool techniques from you guys. But on the statistics side, it's like, yeah, but basically it's almost GIGO. If the underlying data is garbage, you're going to have, no matter if you have the best analytics team in there, the analytics is going to be garbage as well. So what I'm looking at is, hey, let's take a step back, because we all got really cool techniques. We're all doing really cool stuff. Let's take a step back and let's look at the fundamentals, stats 101, okay? Like what's going on with the data, how's it sampled? So, and really it's kind of more like statisticians talk to the data scientists, IT people, and vice versa. And really, I think we're all in the same camp. I mean, we all kind of agree on stuff. And so it doesn't have to be a fight. It's not Lannisters versus House Targaryen or something like that. We can all get along. So here's some motivation for my talk. So Pearson was like 100 years ago, statistics and grammar science, and somebody we should all know about, who we should all know besides Hadley Wickham, this gentleman. And he's mentioning that basically just because you have a lot of data, and a complex algorithm doesn't mean what you're going to get, is anything valid. You're going to get something, but is it real or is it like phantom? Okay, so we need to get the statistics. Now there was just the article, I think, is anybody in the ANSTATS group? You are, the 50 Years of Data Science by Donahoe just came out. And the thing is, really, if you look back, John Tukey, he's a statistician, talked about this a long time ago, but really it's just kind of, for some reason, as the techniques have been really cool, like I said, we've just forgotten about the underlying data. So we have big data, lots of data, okay, fine. But in some cases, we still got small data. So some of the stuff we do, now my first PhD work was econometrics and choice modeling, but then formally it's in marketing, my PhD. So we still do surveys, proper experimental design, asking people like, so we might have a couple thousand data points, okay? So really, okay, does anybody use scanner panel data? Nobody use like AC Nielsen, like scanner panel data? Sorry, I can't see everybody over there. Hello. Yeah, so the thing is, okay, so the one thing like for really, so you have lots of scanner panel data. Look at what people have purchased at Kohl's, Woolies. Well, actually, Woolies would be Quantium. But if you have all this data, I'll give you an example. And Eugene mentioned choice modeling. Ready? You're going to the cereal aisle. Okay, so it's like, okay, there's like 30 brands. There's 30 different. If you look at the SKU, probably like 50 different types of cereal. It's like, I choose Crunchy Nut. Okay, so on the scanner panel data said, hey, there was 50 available, you chose that one, so that was one choice out of 50. But it's like, wait, hey, I only look at Crunchy Nut and Cocoa Puffs, that's it. So actually my choice was 1 and 2. It wasn't 1 out of 50. So think about this, if you do like a market basket analysis, association rules, you're totally wrong. That wasn't my choice set, that wasn't my consideration set. The only way we're gonna know that type of stuff, so big data would just look at reams of data and say 1 out of 50, 1 out of 50. But in reality, when we do small data surveys, it's more accurate, less biased. So what I'm here to say is the old school statistics and surveys and what you learned in uni is still valid, and to be honest, probably less biased, because we're getting we control for really the way people shop. So, okay, so that's kind of one of the motivations. And like we all know, good data is the foundation for good analytics. And because one thing, if you guys will kick it back to some statistical concepts you all learned in uni. If you have a lot of, so I just did a really kind of just fun graph with, I took some standard deviation. Remember standard error, anybody? Remember this from 20 years ago? Okay, so basically you got your standard deviation divided by square root of square root of e nose. Okay, good. All right, but basically notice this. After about 1,000 degrees of freedom, there's no appreciable, basically, I'm at such a small standard error, every parameter estimate is going to be significant. So what I'm saying with big data, piling on more big data, whoop-de-doo. I mean, well, that's the technical term, whoop-de-doo. Yeah, so basically, once I go beyond 1,000 data points, there's no appreciable gain. Everything's going to be, so why do I need 10,000, 20,000, a million? It's gonna, the standard error is relatively flat. So that's the other thing too. One of the problems with big data and not appreciating the statistics is any large sample, yeah, is gonna be statistically significant when in fact it may be bogus. So we need to shake it. So this is where, when I did the choice modeling, so it naturally, because you have a discrete dependent variable, yes, no, buy, something like that. So it naturally gives, so when the data, I was telling you, Gene, even though, yeah, I technically knew Brian from like, I don't want to admit my age, but 30 years ago. So I technically from then, but I probably didn't appreciate anything about, I was an undergrad, so I probably didn't appreciate until the mid 90s what CART and data mining can do. So one of the things in the article that I mentioned with the big data article by Donahoe is, we talk about this skills gap. There's not enough people out there that know. Well, his idea is that basically really it's a knowledge of statistics gap. Because a lot of us, I'm sure, I don't know if anyone here is trained as a statistician or myself as an econometrician, but you have to learn programming. So how did I learn SQL and R and Python and pandas in the house? But how you learn all this stuff is you just do it like on the job, you kind of, picked it up. So really but I think people like Eugene who came from the IT space so some people came from the IT space and learned statistics, some people come from the statistics space, learn IT, and that's supposed to be the data scientist, right? The crossing of the two. So really this is like, we really have to make sure that the underlying data is good. Now as a marketer, sorry, I've got that too, this really kind of pisses me off because I think here marketing has a bad rap. There is marketing analytics, which I do, and I think like I'm the only one doing it around it. So only 5% of marketers actually own a statistics book ever, okay? And the other thing too is 11% of marketers still make their decisions based on just gut instinct. Yeah, just like, oh, it's always been that way. So really not data-based. So really, for me personally, now you guys are probably in a better position. I'm kind of battling uphill battle. Yeah, trying to get this, like, not only am I trying to get analytics in, but even then go to a deeper level and correct statistics. So it's just been an uphill battle for me. And even reading some of these trade journals where they're saying like, oh, the key is not the data, it's how we communicate the data. No, the key is the data. This is from, I won't mention the journal because it's probably libelous, but this is just a marketing trade journal. No, don't worry about the data. Yes, worry about the data. So I said, it's gotta go. Art, you got bad data, you're gonna have bad analytics. Okay, so why missing data? Well, missing data are problems within a data set that you statistically need to address. Okay, so this definition I don't really like, but I put this here, it's valuable only if, if we had them, they're valuable, otherwise who cares? Here is the problem with missing data. It's in your face, you have to deal with it. Okay, so ready? Let's say it's basically, I don't know, this is the way I do my inbox, complete it or delete it. I don't know if anyone has that. It's like delete, oh yes, answer, delete. So it's the same thing with missing data. You either have to address it, either ignore it and chuck that observation, or somehow impute an observation. There is no choice. And guess what? Both ways have consequences. So Don Rubin, who's, I don't know if you've heard of anybody who does any type of missing, well, if you did the EM algorithm, anybody use EM algorithm, you're gonna hear Rubin. And I was actually fortunate, he was giving a seminar down in Canberra at the ABS a couple years ago, and I was fortunate to be there, and it was on missing data, and he's like, and here's the thing, there is no right, in some, hello? Oh, okay. Okay, but, all right, so what he said was, there is no good way. I mean, now there are better ways, but it's not like you're maximizing a likelihood, it's not like you're at the pinnacle here. Some ways are better than others, but they all kind of have issues. So that doesn't really help. So I mean, it's one of these things like, okay, so because of that, some ways are better than the others, we really need to go back on our statistics 101 principles to make sure that missing data is somehow addressed properly. Okay, so why do I care about missing data? Because if you're using a choice model, it's a parametric specification. We can't afford, and we only have like 2,700, 3,000 records, I can't afford to chuck a row. Okay, but if you guys are doing truly big data, you got gazillions of records, chucking one row, who cares? But then who does care is the problem if you chuck it. So remember I told you got to complete it or delete it. If you delete it and it actually was having an effect, yeah, you're going to have biased results. So just like, oh, I don't like it, it's gone. Okay, well, that's cool, but you're going to bias your results. And you're going to deploy a model that's not good. Okay, so the best way is clearly at the get-go, have like a validation field, like anybody who's on database programming, have a front end that doesn't let these go through, but sometimes when we have surveys, especially with demographics, and I'm going to use some medical data sets later, because usually the ones that are replete with missing and there's actually reasons for it are usually medical databases. So a lot of the missing data research is actually in the medical space. So here we have I just randomly have from a choice data set, some data. We'll notice here's some missing data. So let's just looking at age and income. So there's a thing we call list-wise deletion or complete data, which basically says, look, if I'm only looking at these two characters, here's my target or dependent variable, I'm just looking at these two, well, this row's got missing, so even though I got to complete here, this is what we call item non-response. So I have to chuck the whole row. I have to chuck this whole row, chuck this whole row, chuck this whole row, and I'm left with this. So notice what's now happened to the mean and the variance. So here, the mean has changed and the variance has increased. Going back, means changed, variance is increased. So I've actually, like say, I've increased the variance in my data set, so my stability is going to go bye-bye. Well, I got to present more, more technical. Yeah, it goes away. There you go. Let's go bye-bye. Yeah, so your estimates are now highly unstable. So that's not a good idea. Okay, so what has anybody been taught mean substitute? Like when you were back in the old days, like taking your, were you taught mean substitution? Like, oh, when you don't know, just plug the mean in. I mean, that's like the worst thing you can do. But were you taught, okay, I mean, I'm just saying if you're taught that, you really shouldn't. Okay, because here, so I did it. Let's just plug the mean in. Okay, great. Now what's happened is the variance is, the variance is artificially deflated. 2, we've actually changed the structure of the data and the interrelationship of the data. We're now saying that here, these people that are 34.29 are just as likely to make 34,000 or 53,000. We've now changed the relationship in the data. So it used to be like, hey, it's bad because you're reducing the variance. That's true, but you're also altering the structure of the data, which equals future bias. So really, with missing data, how it got in, usually, this is what makes things even worse. Usually we don't even know what the structure. Okay, now let me take that. Like in medical databases, sometimes they do know, like if their blood pressure greater than X, then don't even ask this question. So don't even ask, I don't know, I'm just thinking off the top of my head. So usually there's a structure. Okay, so we call that not missing, that's missing not at random. Now this is where some of the nomenclature, the lexicon gets kind of tricky. The missing completely at, okay, so it's like missing at random or missing completely at random. They're actually, this one's not really missing at random. It's a funky terminology in the missing data field. When you say it's missing at random, it actually, there is probably some reason. Now in marketing and medical data science, okay, quintessential example in marketing, income and age tend to always be in terms of demographics, people omit those because they're sensitive about that, okay? So there is a reason. When it's missing, it's not just a random reason. And then medical databases, especially for insurance, like they're worried that the insurance company might get a hold of that data. So there's a reason why, okay? So this means there really is absolutely, it's just totally random. Oops, something happened. This is where there was some reason why for sure, like, but some very systemic and discernible reason. But usually has to be, you have to have some outside or domain knowledge to ascertain what happened. This is actually our safest to assume is the MAR. It's like I say, there's usually, you don't know the structure, so it's safe to assume this. Okay. So within it, now you could just run it, if you have a missing data point, how are we doing this? If you have a missing data point, you could just do a regression and just, you know, from the complete data and then just estimate, hey, when it's missing, this is my best guess of that value. But that's what we call a point estimate. That's a single point estimate. But because it's unknown, and I go back to the random, central dogma is there is randomness in the data. So we need a technique that has some natural randomness. Now I use these two techniques, and it's something I talked to Eugene about beforehand. Okay, so I'm writing this article, and I got some interesting comments back from the reviewers, to convince the marketing community, the marketing managers. So therefore, everything I'm going to use, I know SPSS for this. I'm not using R. I apologize. But it's just because these are. It's easy. It's in SPSS. It's already there. You don't need to work. Now I know people say, "What about hierarchical Bayes?" We'll get into that later. But I'm just saying for this, it's off the shelf, easy to use in SPSS. Okay. But I'm also going to, like Eugene was saying, I was going to use cart trees because they're easy, off the shelf, and a white box approach. Okay. So the way I roll is the following. I like all my data wild caught, and I like all my algorithms wild caught. What do I mean by that? The data I like is, I just take it as is. I do not massage it one bit. With the algorithms I use the default parameter settings. Why do I do that? Because we're trying to get, like I say, marketing, only 5% have a stats. I'm trying to get buy-in in the marketing analytics community. Yeah? So what I'm trying to say is like, look, I'm not going to tweak this at all. Let's see how we do. And that's what one of the reviewers comments. I can skip ahead really quick at some results. Maybe not. Okay, here. So I just showed how using expectation maximization with CART, it had the best log likelihood. And one of the reviewers is like, well, it's only a smidgen better, who cares? And I'm saying, but that's my whole point. Maybe that was actually my fault, I probably didn't make that in the article. I go, look, I just like taking the data on natural. I didn't tweak the algorithm, I didn't tweak the data. It's just as it is. And guess what? I already win. So if I tweak it or use some domain knowledge, I can only do better. So this is what, this is the issue I have, I don't know if anybody else in marketing, is that I have to kind of convince the people that, yeah, this is going to do better. But like I say, by massaging the data, you're not helping your case. Okay, so let me go, where am I? So I went ahead of this. Okay, so this is why I use MI. Okay, but there are some, but the cool thing with MI and EM, multiple imputation, both of them available, they have some natural variability. It's not a single shot impute. So there is actually a distribution to the impute. And so the thing is, these are usually main effects models, just x1 plus, beta 1 x1 plus beta 2 x, 2. And they usually only do well with metric data. Okay, great. Now all of us know how much metric data, how much unstructured versus structured data is being created nowadays. It's like 80% unstructured. And even within the structural relational databases, it's non-metric as well. So according to Dawes and Corrigan, okay, great, main effects, we got 70% of the variance. Well, there's 30% left. And the other thing is, most of the data being created now is non-metric. So these methods do well on metric and main effects, but like I say, this is not really what the state of play is. We need something that does non-main effects, interactions, and using non-metric data. So what came to my mind? 4 names: Bryman, Ocean, Friedman, Stone. Because the CART algorithm, first of all, it's transparent. Okay, that's another thing with getting buy-in. Now, of course, could I do RF or something later? Sure. Will I? Of course. But as a first step for selling it, let's just something very transparent like a decision tree. So easy. You give us a business, they understand. So yeah, I was thinking I'll just do CART trees. It's easy to show a client or an academic a CART tree, and it's easy to show a regression model. And then I just say, look, what I got from this CART tree, I just plug that in to the regression model to boost the accuracy. And it captures the interaction and non-metric effects. So usually, I don't know, what we were taught in statistics was you had an interaction, it's like X, I don't have a whiteboard here, like X1 times X2 times X3. Okay, so a lot of times they were garbage, they didn't help the model. Well, the reason was very simple. If I had an interaction of age with suburb, age was, let's say, 18 to 90, well, so the interaction had to act over the entire data space of people from 18 to 90 years old. It's highly unlikely, and according to Bryman, most of the salient interactions are not, it's going to be perhaps age 30 to 35, living in postcode 2060. So it's going to be, actually, it's more likely it's not over the entire global data, so it's local areas of the data space. So, and this is actually, Friedman already mentioned that in his Mars paper. So we need to basically, what do we need? So I want to get those interactions for that 30, so we got 70% of the variance from the EM and MI just using main effect. I need to get that 30% with interactions, but according to Bryman and Friedman, I need localized interactions. So decision trees are clearly going to be the winner for this. All right, so I simply, like I say, I put the main effects in. I use CART to find the interaction reasons, and Dan Steinberg and Scott Cardell already postulated this many years ago that you can use the interactions from CART basically they did it in a logit model, so you can hybrid it, and that's basically what I did. So I added it in, so I have in the EM, and so I did a simulation. So here's a CART decision tree. Everybody can see how it works, right? This is the diabetes. Does anybody remember this data set from the UCI? The diabetes data set? It's been around for yonks. But the reason once again, it's a medical data set, so there's usually if people omit missing, they don't want to say something about themselves on purpose, like medical, they're like ashamed or whatever. That's why medical data sets are really good. But anyway, so this is the diabetes, which I use as one of the data sets. So it's easy to understand. So here's the results. So I use I actually did a bunch of simulations. I varied the amount of missing from like extreme amount where like 60% of the records had some type of missing data in it. And then I just, so then I did in the simulation, I ran EM, expectations maximization, I ran multiple imputation, then I ran both of them adding the cart interactive regions as well into it. And when it was the data was missing at random, which means there's a wee bit of structure, and in the simulation I kind of created some artificial structure in making the synthetic data sets. And EM with cart won. Not by heaps, but like I say, you can always with domain knowledge make it better. Now, can you see the shades of gray? All 50 of them? Can you see them in the? Can you see? But you can see it here. But sorry, I didn't know it didn't.
Yes.
It's appearing there. Oh, okay, it's appearing there. So this is actually now. This is the other thing too. As a true academic, sometimes no finding is a finding. I mean, as a true scientist, right? Because sometimes it's like, we did this and we found nothing. Well, that's a finding. Okay, so this is missing completely at random, which means there's actually no little structure. There's no structure whatsoever. And guess what? This is all over the shop, which is what I would expect. Because there is no structure, adding cart should neither boost nor detract. It should do nothing. And that's why it's all over the shop. So the MAR was like dead solid. Yeah, that did with that. So there was a wee bit of structure in the missing, but when I purposely had data sets that I simulated where I totally made it totally at random, I think I just used some like uniform distribution for the randomness. But yeah, it didn't find anything, which is what we'd expect, no finding. So here on an empirical, those was simulated data sets that I made myself. On empirical data sets, one was on people buying shoes, and the other one was the diabetes data set. MI actually did better. Missing multiple imputations does better when you have more regression-y, metric, more numeric type data. So the MI did better than EM. So yeah, but in both cases, this is list-wise deletion, mean substitution, multiple imputation, expectation maximization, and then here's the MI and the EM with the cart interactive regions trying to squeeze that 30% out. So yeah, and in the empirical data sets, it won because these are wild-caught data sets, real life, and especially in medical, there's probably a reason why people omit, okay? So yeah, the whole thing is about, with the data set, we need to retain the records, especially if we're doing some type of parametric estimation. So if you don't, if you just like say omit, you have big data, or you improperly impute or just delete the records, it's highly likely you're going to have biased results. So like say the science, what I look at as the science of data science is making sure the underlying data is good. And what's going back to what the what I was saying before with the skills gap is a statistics gap, what a lot of people at the conference are saying, it's not even like knowing statistics, like this is a mean, this is a regression. What a lot of the statisticians were talking about is we need to go a level deeper, like how was it sampled? Real simple, basic, like how was it experimentally designed? So we need to go to maybe one step lower. And the other thing that I want to do one last, because I think I'm over time, is like I say, hierarchical Bayes actually for big data situations may be okay. I didn't use it because in small samples, not as good, and in choice modeling and surveying people costs a lot of money. We're talking 3,000 people. So HB probably wasn't the way to go, but if you got 10, 20, 30,000 people, yeah, HB is nice because it already has a natural variability in the estimate in it. So by all means, I'm not going to bag on HB. It's just for small data, relatively small data sets, it's not as well. Not as good. And we know that as analysts, we need to be able to communicate more with non-statisticians to get them on board. And so me as a marketer in the marketing community, I really go to explain that. Look at Cartridge, so easy to understand, and get them on board. Okay, so that's all I have. Here's some selected. This is like where's the seminal paper? This is, the 1977 Rubin paper. Anyway, sorry, I've been blocked by the wall here. I'm done. Any questions?
Where's the outline?
I know. once again, like, I knew that was gonna come. Okay, I was thinking about the other day, I'm sure I will redo this all in R. Like I said, the reason I did it was a piece to get like the marketing community, which is not as analytical, to try to get them on board. So SPSS and decision trees are really easy. And the good thing is they still win. So I'm thinking, you're right, with other techniques, it'll probably do even better with imputing the missing value.
Hey, did you also try to tweak your, because you said with the EM cart you didn't tweak your data at all, like tweak your model at all? Right?
Yeah, I just used whatever the SPSS, I just used I used the normal distribution.
Did you try to like tweak your parameters as well and add domain knowledge just to see if you can get more?
No, that's, no.
Just in case if there's like, if it actually made a difference at all.
No, that's actually a good one. No, I just threw it in. Now, okay. Now I did add okay, maybe that's, yeah. For the cart, in terms of like, because within a cart tree, some branches are better than others, so you have a better lift. So I did kind of say, look, if the lift is at least 1.2 or 1.4, yeah, okay, so a little bit of domain knowledge, okay. But yeah, it's like unstructured data. There's no such thing as purely unstructured. So yeah, you're right. With the cart trees, I was kind of judicious in which rules I would take from the trees. But like I say, a lift, I think it was 1.4 was the criteria. That's it? That's it? Okay.
All right. Thanks, Ingo. That was awesome.
Thanks, Eugene. Thanks, everyone. Yeah, look, 10th House, been a big supporter of data science for a long time, and I was very happy to start, as I said last time, start paying back and pizzas and everything for everyone. But look, 10th House, I'm the analytics lead at 10th House, very much all focused around analytics, BI, and digital, and where they all sort of come together. Basically, here is a resource for the data science community. If I can be of any help, answer any questions about recruitment. Recruitment is quite a hot topic now around the data science community. If anyone's got any questions, more than happy to answer. Or if anyone's looking to build their teams, please come and talk to me. There's some very good individuals out in the marketplace at the moment. Please have a look. I meant to have our website up, but it's 10thhouse.com.au. Have a look at the jobs on there. And please, if there's any questions with regard to that, please come back to me.